data has to be completed by the 24th.
Yes, by next Tuesday.
But that's not gonna work.
What?
If that doesn't work, then you need to talk to me about it, because that would have been like 7 or 8 days, so it should have been. What?
By the end of next Tuesday?
I'm going to be checking next Tuesday.
And everything has to be complete. Unless
You
you
have-
check it today.
I'm checking tomorrow to see if you've started. So tomorrow in class, if you've started and you have one track of data, you will get 100% on a homework grade. If you have not started, you'll get a 0% on a homework
So
grade.
say we have one track of data tomorrow.
Then you will get a homework
Is
grade.
it possible to get all of them done by the 20th?
Yeah, you go home 2 times a day. Will you come here?
So let's see. Today, so today's a trip going home. Thursday there's 2 days. Friday there's 2 days. Monday there's 2 days.
Tuesdays is 1 day.
Tuesdays is 1 day. So if you have not yet started by today, you still have 8 trips. And so that
So I need to start like now.
I mean, you should have started a week ago, well, not half a week ago, ideally. But if you have not yet started, you need to start now. You need 8 trips.
So 8 one ways, so 4 full.
If you didn't do this morning, you're doing every trip for the rest of the time.
What if I do tonight and tomorrow morning?
You have to do every trip. That's 2 trips.
Yeah, but I only did like half of the trip. So is that okay? Like, because it's not on the same day. You know what I mean?
I mean, we want these to be different trips. I'm saying, so like 2 school is 1 trip.
So I'll
Home
get
from
100%
school is a
tomorrow if I
second
do
trip.
tonight and tomorrow.
If you do 1.
Oh.
But I'm saying that you need to be starting now if you haven't, in order to get 8 by next week. Heather?
One thing I'm a little confused about, do we have to record the time it takes for the entire trip?
Yes.
How would we use that data then?
That's what we're going for at the end. Like the end is to try to get to that number, to make something that predicts it.
But don't we just really need like the information about the time, cost time-wise?
Well, but the idea is to make it a model that predicts the time of transit, and so we need we need to know how long it takes you to go, in order to be able to say if we're predicting it well.
So we need to have like 2 stopwatches.
Well,
One to be recording
yes,
the
or you
tip.
need to be willing to accept like fuzzy numbers for the things in the middle, or you could look at your stopwatch when you stop and then try to assess. 2 stopwatches is probably the easiest way. Yes. So the idea is you need the total time of the trip. You want to kind of make a log of how many stoplights, traffic signs, turns, how many, and then you need to try to assign a weight to how long they take. So like,
you
if
mark
you,
how many stop signs we pass, how many lights we pass.
yeah. So if you look at the videos that I kind of, sort of made, you can kind of get an idea. So like every time I stop at a traffic light, I start counting to see how long I stayed there.
So am I doing it wrong if I...
Yeah.
Okay, so I...
I mean, if you just slow down and roll through it, then I would say it doesn't cost you much.
Okay, I did.
Like that's the kind of thing, like, you might want to note if you were slowed down for anything substantial, but like, I would focus on things that are definitely adding transit time, so things where you're definitely stopping.
Yeah, like a stop sign, but you said I don't. I said 2 seconds. I say that they're there, but I don't say it takes any time.
Alright.
But like my dad doesn't really like he slowly continues. No, like I was like stop sign 2 seconds and stop sign.
Yeah. That's the kind of stuff you're supposed to do.
One light takes
For the first
36
time?
seconds. Why would
Yeah.
I ever use one light to go?
I get stuck at the light at Forbes and Shady for 2 minutes going home on Friday.
Yeah, we just.
What if your phone doesn't have a time?
How does your phone not have a timer?
I
Are you
can't.
find
serious?
No, your phone has a timer.
What kind of phone do you have?
A droid?
I have
That's
your
gotta
phone
have a
has
timer.
timer.
Do you try to look at like tools?
No, if you go to
Really?
clock, just use your phone clock.
Alright, if you need a timer, I have stopwatches you can borrow.
Can I borrow one?
Yes,
Like right now?
sure. Well, I mean, I would,
Where are they?
somewhere over here.
Are you still recording?
Yes, I'm still recording.
Okay, can we draw some pictures?
Can you talk about like the different ways
Or
there's
video?
lenses?
You want to?
Me 4.
Really? This many people do not have phones that have.
But I need 2.
Alright. I can't give out I don't have enough to give 2 to everyone, so.
No, I have one for my phone.
Yeah, but so that means well, you need it to the second accuracy, basically. Alright. Yeah. But if I don't have enough to give everybody 2 stopwatches, so I can't give anybody 2 stopwatches.
Rauhala, I've just been saying like I started 7:01 and I get here at 7:36.
I mean, you need to have better accuracy.
Like 2 seconds.
So at least to the seconds. I mean, if we're caring about how many seconds you're stopped at a traffic light, then we have to care about how many seconds it took you to get to school. Basically. All right. Yeah. Got it. All right. Back to the test. What were we talking about? Pictures. What do we want pictures of?
Concave mirrors.
Concave
And
mirrors.
convex and plane mirrors.
And lenses.
And spheres. And
Okay.
Everything that I would do for sure.
Tell you what, since we don't have enough time to redo everything we've learned in the last month and a half, why don't we pick some things that we're specifically interested in? Is there anything in particular that we want to review?
Yeah,
Lenses?
What about
Lenses.
lenses?
Diverging lenses.
Yeah.
Divergent.
Oh, I
All right.
remember lenses.
So, this, yeah, probably.
I like
All right, so here we got a diverging lens. Where do I want to put the object?
10 centimeters away from the focal length.
The focal length?
Sure. To 20 centimeters away from the center point.
Sure. I'm not actually going to worry about the numbers so much. So let's say this is where F is. We've got an F on both sides, right?
Let's put the object.
Well, is that a call for outside? All right, so here's my object. What rays do I draw? So the wonderful thing about lenses and mirrors, you are always pretty much drawing the same things. That's the reason that we bundle all this stuff together. It's supposed to be easier when taken in bulk because you're really only learning like 2 things at once. Yes, so diverging lenses are weird like that, but basically the 2 things that are common for some lenses and mirrors, we go in parallel out through F, we go in through F, out parallel. That is probably the single most important thing to memorize.
Which F do you go through?
Well, that's where it gets weird. All right, so this one
So in parallel, out through F.
goes in parallel. So since it's a diverging lens, I know it has to bend outward on the other side, right?
Yeah.
So it's not going to go through this focal point because that would be convergent. So that means that when it goes out through this focal point.
Which one do you?
And with diverging, you're always creating an image that's not.
A virtual image. Yes. Zoe?
Do you measure the like from the middle of the
Yeah.
lens?
The idea what we're always doing is a thin lens approximation. So we're always assuming that the lens doesn't really have any size.
Does it turn
So the
at
lens
center?
should basically be the actual lens is just the center of this thing. That's the only thing that's actually there.
So
So
the second
everything
step
bends at the center. Yeah. The center is the thing that's important. That's where the lens actually, for all this math to work, that's where the lens is. This is just cosmetic. All right?
Are you ready?
Yeah, we always have to draw 2. So what are the other rays we can draw?
You said in
In through out parallel. There's a third ray for lenses though.
Isn't it in through?
Yeah, we can go straight through the center. The center is a nice easy one. So we just kind of go, line up the center, which is apparently more difficult with this for some reason. That's a straight line, sure. So, do these real rays intersect? No, so then I have to extend them backwards. So this ray, I extend backwards into the real side, and this one is not deflected, so it is its extension. So where they intersect is right here. So there's my image. All right? These are the basic rules that hold for every kind of picture we draw. It's always going to be something like this. All right? So we're always drawing one in. All right, let me draw the third ray just so for completion's sake.
How did you get
How did I get what?
the one ray coming down?
This one? So since these real rays don't intersect, I extend these backwards to find where their virtual rays intersect. So this one going out, I extend back into the real side.
How do you know which one?
Since I know this is a diverging lens, when it goes in parallel, it has to go through F. If it's divergent, it can't go through this F because that would be convergent. So it's going to go through that. Right?
How do you get like the other ray? Like the never
This one?
Yeah.
It's going through the center. And if it goes through the center, it just goes through the center. The third ray we could draw is one that goes in through F. And so it's going to go through the far F since it's divergent.
So it can either go through
So it
the
goes
center.
in through F and then goes out parallel. If it goes out parallel, I extend this back, and miraculously they all intersect at the same spot.
Wait, what do you mean it went through F?
So this one is aiming for the far
Oh,
F,
and then it went parallel.
and then it went out parallel.
It went parallel at the center.
To the line.
Hmm?
It
It went parallel to the principal
right,
axis.
to the back.
These two rays are pretty much the opposite of each other. Right? This one goes in parallel, bends out through F. This one goes in through F, bends out parallel.
Do you use that equation for all of mirrors and sphere
Yeah.
mirrors?
This
And-
equation holds for spherical lenses and or for spherical mirrors and for lenses. All right. Other questions?
Can we do convergent?
All right. So we did converging lenses. It's basically the same thing,
Or
right?
can we do one of the mirrors? Like the spheres?
All right. Well, since we've done a lens, why don't we do a mirror? Just, I mean, we've only got like another 10 minutes. So
We have like 20 minutes left. And
this
it's
class ends at
25.
11:25.
Yeah. Let's just do it.
So we have 15 minutes or so.
We just do it.
Well, let's do a mirror, and then we can go back for a lens. Back. All right. So.
What is this one?
Whichever one we want it to be. Do we want it to be concave or convex?
Convex.
Convex. All right.
So does that mean the image? What does that mean again?
Image coverage.
That's why you want the table for tomorrow.
Oh, we can bring the table?
Yes. Did you not read the homework where it says you can bring the table? Maybe I'm not going to record stuff in the future then.
I'm paying attention.
All right. If I want this to be convex, do I put the object on the left side of the mirror or the right side of the mirror? Left side of the mirror. All right. So here is
What is that other point like next to F?
the center.
Oh.
So there's my object. What rays do I draw?
Oh, so if it was concave, the center would be on the other side.
Well, the center is where the center is. The object would be on the other side.
Okay.
So since the object here, this is convex. I'm looking at this thing and I see kind of,
Convex is when it was like the bowly kind.
Yeah.
You're facing like the bowl. Like, okay.
yeah. It's convex if it comes out at you. It's concave if it caves in away from you.
Okay.
All right. So, what rays do I want to draw here? The focal point for a spherical mirror is halfway between the center and the mirror. So here's the mirror, here's the center, in the middle, focal point.
So even in concave.
Correct. The question is, though, is this focal length positive or negative? Same thing happens with lenses. All right. So, what rays do I want to draw?
You're gonna draw one
Parallel?
All right, see it.
Yeah.
In parallel. That's always a good starting. It goes in parallel. What does it want to do?
through the focal point, like that way.
Yeah, so it wants to go in through F, right? But so it can't do that, so it bounces off, though, in this direction. Yes. Lenses bend, mirrors bounce. That is hopefully apparent at this stage of the game. What's the next ray I want to draw?
Do the focal point?
In through the focal point. So I connect the object and the focal point, and this goes merrily along until it hits the mirror. When it hits the mirror, what does it do? It goes out parallel. So, are the real rays going to intersect?
No.
No.
No, so what do I have to do?
Go back.
I have to extend them back. So there is my image. Yes.
When you're doing the math with lenses, when is the focal length positive and when is it negative?
The focal length is positive for a converging lens, negative for a diverging lens.
Okay. And for mirrors, it's negative if it's on the virtual side.
And it's positive for a concave lens, and negative for a convex lens.
So the image is virtual.